Hello everyone, and welcome to another math video by me, Jake the Tutor. And we're going to revisit logarithms now, and we're going to talk about the change of base formula, which lets us be able to use like base 10 logarithms to solve any base of logarithm. Which you'll see what I mean in just a moment. So I'm going to get out my draw tool here. Okay, so to kind of preface this, let's just... Alright, so I'm going to pick a number that's not 10, just to kind of, I guess, show that we can do this without having to use 10. So let's, I'm going to choose 8. So we're going to go like, so 8x will equal something. But let's go ahead and just choose x, so that way we kind of know what to expect, and you'll see what I mean in just a moment. So let's choose x to be. Let's just keep it simple and go with 2. Oh my gosh! Come on. Okay, this is weird. All right, so 8 squared. All right, so 8 squared we know is going to be 64. 8 times 8 is 64. All right, but now we're going to pretend that we never did this. Alright, man, this never happened. We're back to 8x equals 64. So okay, so here's our problem. So we're given the problem that 8 to the x power is equal to 64. So besides the fact that we can just kind of look at this and say that it's asking us what exponent do we put on 8 to get 64, and realize that, you know, the square root of 64 is 8, so that would mean x is 2. We're going to use logarithms to figure this out. So the thing with logarithms, we kind of reviewed or learned last time that when you take the log of a number, and this can be this can be base, like this bit, and the logarithm's base can be any number. It can be any base we want it to be, and it will still work. So like if we take, say, the log base 2 of 5 to the x power, it still becomes like x times log base 2 of 5. And you know, it's like similar, like if we use the log that all calculators have, like log base 10 of 5 to the x, this still becomes x times log base 10 of 5. So it doesn't matter what base logarithm we use, it still pulls the exponent down and puts it out front as a coefficient. So keeping that in mind, actually, you know what, I'll just leave that there, because that might be important for you to look at. Alright, so we're going to let's start by okay, so let's do this so that way we can, so that when we take the logarithm of both sides, so when we take the logarithm of both sides, we can cross out the logarithm of some base of 8, so that way it equals 1. I'm sorry if that was confusing, but that's just going to mean that we're going to take the log base 8 of both sides. So when we take the log base 8 of both sides, this becomes, okay, so I'm going to do this step by step. This becomes the log base 8 of 8 to the x equals the log base 8 of 64. So the next step is that since we took the log of this, of 8 to the x power, we can pull down the x and put it out front as a coefficient. So this becomes x times the log base 8 of 8 is equal to the log base 8 of 64. So whenever you have the log base of some number of that same number, like so when the base and the argument are equal, then that equals 1. So this equals 1. Oh boy, the roommates are talking, and it's probably picking up on the microphone. But we'll press on anyway. So this leaves us with x equals the log base 8 of 64. which is all fine and good until you realize that your calculator only has log base 10. You don't have log base 8, which is sad. But it's okay, because we have a backup plan. Let's bring out the drawing tool again. Let's do the same problem, but we're going to use log base 10 this time, which our calculator does in fact have. So here we go. So we have 8 to the x equals 64. This time we're going to take the log base 10 of both sides. And I'm going to do the first step, but we're going to skip this step here and go ahead and pull the x in the exponent out front as a coefficient. So we have the log, or 8x times the log base 10, which I'll just leave out the base and just put it as log of 8 is equal to then the log of the same base, which is 10, log base 10 of 64. And there it is. Alright, so then we can solve for x if we divide this log of 8 to the other side. So we get x equals the log of 64 divided by the log of 8. And this is something that we can actually put in our calculator. So let's go ahead and do that and see what we get. Now remember, we should get 2, but we're just keep that in the back of our heads for now, because technically we don't know what x is, even though we totally do. So here we go, 64 log, so here's log 64, we're going to divide that by the logarithm 8. So log 64 divided by log 8, and that equals none other than 2. So let's go ahead and put that there, boom, 2. So we found out that this is in fact true. And going with the property of algebra that when you have two things or two expressions equal to the same thing, then those two expressions are also equal. So I'm going to, and since we have log base 8 of 64 is equal to x, we also have the log base 10 of 64 divided by the log base 10 of 8 is equal to x. We can set both of those equal to each other. And we get the log base 8 of 64 is equal to the log base 10 of 64 divided by the log base 10 of 8. And this is the basis, or this kind of shows us how the change of base formula works. Change of base. So we notice here that we see familiar numbers in both of these. We see that the argument of this side appears up in the numerator over here, and we see that the base appears in the denominator of this log. So in general terms, if we have the log of base b and we take this log of some number or value a, this is the same as taking the log base 10 or base anything for that matter of the argument divided by the logarithm base 10 of the base. And this changes the base for you. And so this also proves that we don't need specific bases on logs in order to solve problems. All we need is the log base 10 or the natural log, which we'll get to later, and we can solve any sort of logarithm problem. So I guess, where's my cursor? Here we go. So I guess this bottom expression here is more like the change of base formula than this here, but it's basically the same thing. It's the same deal. And so that is the change of base formula. And so in the next video we'll get into some more properties of logarithms that are useful in solving certain equations or useful in certain circumstances. So Till then, I will see you in the next video.